Assalamu alaikum everyone. Today's video is on solving a few circle theorem questions as requested by a few people. So let's get started. I've got a few questions I'm gonna try and go over in the time I have, inshallah. Okay, so here, before I start solving any circle theorem questions, I look at the diagram and I try and identify what the diagram is trying to tell me. Now, none of these diagrams are drawn to scale. I've got a circle over here, with the center O. Quite clearly, OA is the radius, and so is OB. AB, AC, and BC are chords. They form a triangle, and the chord AB meets a tangent EAD over here. So before I even start reading the question, I start looking at, okay, what are the possibilities? I can see that triangle AOB is going to be isosceles because of the two radii, which means this angle is going to be equal to this angle here. Okay, I know that the radius and tangent meet in 90 degrees, so OA is a radius and EAD is a tangent, so this full angle here is 90 degrees. Okay, so that would mean that this angle in blue over here would be 90. So angle, let's call that angle OAB. So I'll start off by saying angle OAB is 90 minus 56 degrees. Okay, and that would be 34 degrees over here. So if this one is 34, this one is also going to be 34 degrees because base angles of an isosceles triangle are equal. And if those two are 34, that's going to be 68. Then you do 180 minus 68, and then you can work this one out. Okay. Also, I can see that the angle between, let's shade this one yellow. This angle here, which let me shade around the 56, so we can see the 56. Okay, this angle here is between this chord, it's in this segment here, between the chord and the tangent. So the alternate segments theorem states any angle between a tangent and a chord is equal to the angle in the alternate segment. What that means is any angle that starts from one end of the chord, touches the circumference, goes to the other end of the chord, is the same as this one. So this angle here is quite clearly 56 degrees. Okay, and then if this is 56, this is the angle at the center. Angle at the center is double the angle at the circumference, so it has to be 112 degrees. Could do 180 minus those two, still get 112. What's the question asking me? Work out the size of angle CAO, which is this angle here. That's the one I need to work out. Okay, so far I've worked all of these out. It's not asking me for any reasons, so just explaining this would be sufficient, I think, and then I have to obviously write down the working out. And this angle over here, angle BOA, is 360 degrees. So because angles around a point add up to 360, so it's going to be 360 degrees minus 112. So that'll be what, 260 to 50, 248 degrees. So this one here is going to be 248 degrees. Okay. Now, if I look at this carefully, that's 1, 2, 3, 4. That's a quadrilateral. It's a four-sided shape. Okay, and angles in a quadrilateral add up to 360 degrees. So what I can do is I can add 35, 248 and 56 and take it away from 360. So I've got 248, 35, 56. Add them up. 13, 19, carry the 1 over, 5, 10, 13, carry the 1 over, 339, and then I do 360 degrees minus 339. That's gonna be 121 degrees. So this angle here is 21 degrees. So I'll show you a working out. I have shown my working out. 21 degrees over there. Okay, and there we go. That's this angle problem solved. It's not asked me for my reasoning. That's why I haven't written down any reasons. But if it did, I would have to structure my answer slightly differently. But the answer for this question is 21 degrees. Okay, let's go to the next question. Zoom in so we can see the diagram. Okay, again, just quickly, diagram shows OB is a radius, O is OD, so that means BD is a diameter. This means that this is a semicircle. Angle in a semicircle is 90 degrees, so let's make a mark over there, different color. Yeah, so this angle here is 90 degrees. Radius and tangent meet in 90 degrees. They already tell you this is 35. 90 plus 35 is 125. 180 minus that is 55. So the angle is 55. Don't know whether I'll need it or not. Okay, let's see. B, C, D are points on the circumference of a circle. Center O, AO is 7. Angle ABO is 90 degrees. They give that to us. OAB is 35. DBC is 70. Explain why angle BCD is 90. Already mentioned that. Angle in a semicircle is 90 degrees. Okay, calculate the length of BC, which is this, to 3 significant figures. So what I'm going to do is I'm going to use some trigonometry. I'm going to start off with this angle here. Okay, in triangle OAB. That's my opposite side. That's my adjacent side. That's my hypotenuse. So I'm going to use the sine ratio because I need to find the opposite side. So we're going to start off by saying I'm going to draw the triangle for the sine ratio. And I need to find the opposite side. So I'm going to cover O, and that's the hypotenuse times sine. So the opposite side is, let me just try, OPB equals hypotenuse times sine. So the opposite side is OB, and the hypotenuse is 7 centimeters, which is AO, times sine 35. Okay, and then I'm going to type that in my calculator and see what answer it gives me. I need to check first my calculator is showing a capital D at the top because we're working with degrees. Okay, and this gives me an answer of 4.015035054. It's important I keep the whole number. Okay, and once I've got that, I'm going to now double that answer because I've got OB here. So if I double it, I get the whole diameter, which is BD. And then once I've got that, in this triangle here, I'm going to be looking at this angle. I need to find this side here, so that's going to be my adjacent. That's my opposite, sorry, not my hypotenuse, that's my opposite. And this here is going to be my hypotenuse. So what I'm going to do is I will have to use cosine because I'm finding my adjacent, and I will have my hypotenuse, which is twice OB, because OB is the radius and B is diameter. So BD is equal to 2 times OB, which is 2 times this number. I'll just write it as 4.015 dot 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 multiply by 2. This gives me 8.0300701 09, and it carries on. Okay, remember I said I need to find the adjacent, so I'm going to use the cos triangle now, and I need to find the adjacent, so I'm going to cover the, and that's hypotenuse times the cosine. The hypotenuse is 8.03007. I'm just going to put some dots here, so that carries on. We're finding the angle was 70 degrees, so we're multiplying it by the cosine of 70. Can't write my C properly at the moment. Okay, so I multiply these two with on my calculator and see what I get. So it says 3 significant figures. My answer is 2.746, and it carries on, which is approximately 2.75 to 36. Okay, and that's this question done. Let's move on to the next one. Oh, this one wants reasons. When you need to give reasons for every little bit. Okay, so let's read the question first. This diagram, I can see quite a lot of information. That's 2 tangents from a point. That's tangent from a point 2. PO and OQ are radii. So I know AP and AS are going to be equal. CR and CQ are also going to be equal. Let's see what the question says. PQRS are points on the circumference of a circle, center O. AP, BQ, CRD, and DSA are tangents to a circle. ABCD is a kite. I believe I've done this question before. I'm not sure if I've done this before on my channel, but we'll do it again. Okay, so if it's a kite, one of the properties of a kite is 2 pairs of adjacent sides are equal. So this side is equal to this side. Similarly, this side, so BC, also equal to CD. Angle PAS is 2x degrees, okay. Angle QCR is y degrees, no problem. These two, this is 90 degrees over here, so that means that's 90, and that's 90, that's 90 as well. I can point over here. That's 90 because radius. I'm writing my reason down next to the diagram. And tangent meet at 90 degrees. I'm gonna draw here. Ooh, there you go. That's my reason for both.
Find an expression in terms of x and y for the size, degrees, angle POQ. POQ is over here.
So that's the angle I need to find. Very interesting. Okay, let's get started. So firstly, I'm going to try and find these two angles. This one here and this one here. Because ABCD is a kite, know that one pair of opposite angles in a kite are equal, so it's not going to be these two, because the one pair of opposite angles are always like, there's a line of symmetry going through the kite over there, and those are the equal angles opposite the line of symmetry. Okay, so let's start off by saying angle PO, what's the letter over there at the top? PBQ. Okay, angle PBQ